Ever since the Industrial Revolution in the 19th century, the amount of carbon being released into the atmosphere has been exponentially increasing, damaging the ozone layer. It is one of the main causes for the extreme weather phenomena being witnessed, as well as the rise in sea levels. Modes of transportation are amongst the worst contributors due to their combustion of fossil fuels, releasing not only carbon dioxide but also sulfur oxides and nitrous oxides. This overuse of vehicles shows no signs of slowing down in the future, considering a population which is expected to grow to around 11 billion by the end of the century. Hence, preventing an aggravation of global warming is critical to ensure the safety and future of planet Earth. Electric cars are rightfully being touted as a replacement to these fossil fuel burning cars, with Tesla and Nissan leading this wave of change, but such cars are still too expensive. If it is not the car which will be improved, then it must be the fuel. One of the most popular options currently present is E85, a mixture consisting of 15% gasoline and 85% ethanol. Ethanol combustion is much cleaner than gasoline combustion, meaning it is much better environmentally than the common gasoline-only fuel. Ethanol is produced from a fermentation and distillation process using corn or sugarcane as a basis, after which it is mixed appropriately with gasoline. However, E85 does not come without its own problems which need to be resolved.
A few specific properties allow E85 to be used as an alternative to gasoline. As shown, the energy density and specific energy values are similar, roughly about 2/3 those of gasoline. Additionally, ethanol and E85 are liquids like gasoline at ambient temperature and fairly compatible with engines. Running the calculation through to determine useful shaft work with the assumption of a 30% engine efficiency, we see that about 600 kilojoules per second of useful work are achieved using E85. However, there is still room for improvement. One area includes the food versus fuel debate, which basically centers around the controversy of using arable land for growing food or fuel. Since most ethanol in the United States comes from corn and soybeans, some people believe those crops should go to feeding the population. Additionally, as mentioned, E85 has a lower energy density than gasoline and is miscible with water, which can result in engine damage.
Before beginning our analysis, we created this set of assumptions. We assume the combustion of biofuel in an engine operates as a continuous process at steady state. The reaction operates under constant pressure and volume, and we set a basis of 1 mole per second of fuel entering the engine and a temperature of 25 degrees Celsius as our reference temperature. It is assumed that changes in kinetic and potential energy are negligible between the in and out streams, and that there is an excess of O2 so that the fuel can combust completely. These two PFDs represent a car's engine with the inlet stream composed of the biofuel mixture, one to represent the mass flow and the other energy flow. The inlet fuel is a mixture of 85% biofuel and 15% gasoline. Both PFDs are representative of an engine using either E85 or our version 2.0 using BU85.
Because the process is continuous and energy is neither created nor destroyed, the balance equation simplifies to in equals out. The negligible kinetic and potential energies mean that the energy balance is the heat added into the reaction plus the enthalpy of reaction at 100 degrees Celsius, resulting in the amount of shaft work the engine can perform. After simplification, the shaft work is equal to the enthalpy of reaction of E85 combustion, which is the enthalpy of combustion of ethanol and gasoline, multiplied by their respective mole fractions.
From these calculations, it is evident that BU85 produces more energy than E85 per liter, per gram, and per second combusted within an engine.
BU85 is still not perfect and has some issues that are currently being researched. For example, the bacterial fermentation process used to create it has quite a low efficiency currently. It is also slightly more toxic and can cause damage to plastic components of cars. However, BU85 and other butanol-based fuels are being heavily researched in attempts to solve these issues. Additionally, like in Brazil, flex fuel vehicles are becoming more popular, allowing BU85 to be used without fear of car damage. We hear about it in the news every week. Climate change is getting worse. We desperately need solutions to reduce greenhouse gas emissions. While E85 offers one, with more research and its superior properties, BU85 has the potential to address these issues.